Power functions. A polynomial function that consists of only one term, what we call a monomial, is called a power function. So power functions have the form of f of x equals some coefficient a times x to the n power. So a is a constant, and n is a non-negative integer. So some examples are f of x equals 5x, g of x equals negative 3.2x squared, or h of x equals x to the 11th. Those are all power functions. So we can consider power functions of the form x to the n where a equals 1, kind of like the parent power function. And we just have two groups then to look at. We can have even powered functions or odd power functions. They have some differences and they have some similarities. So even power functions of the form f of x equals x to the n just means that n is an even number. So some key points that will always be on these graphs are negative 1 and 1, the origin itself, 0, 0, and positive 1, positive 1. The shape is a parabola. The only difference in the higher degrees of n, the even higher degrees, is that it becomes more flat and wide near the origin than for lower degrees that are even degrees. Let's look at the odd power functions of the same form, f of x equals x to the n, but now n is odd. Now the three key points that will be on all of these graphs will be negative 1, negative 1, the origin again, and once again positive 1, positive 1. So the shape is a snake, and remember that's always increasing. So here's a table for each of these even and odds. You can kind of look at these values, and for the even functions we have an example of y equals x to the 18th power. Close to 0, all the function values are very, very small. F of x is staying low and close to 0. That's what widens it and flattens it out. And same for the odd power functions. Close to 0, as we get higher in an odd power, the function values are staying very close to 0 too. So around 0 in both even and odd power functions, the graphs tend to be flatter near the origin as opposed to lower degrees in even and odd functions. So let's just make note of that. As the degree n gets larger, the graph grows steeper and faster at the ends when x is either less than negative 1 or greater than 1, and it gets flatter near the origin, so when x is between negative 1 and 1.